Bismillahirrahmanirrahim. In this particular lecture, we have to discuss increasing and decreasing function in calculus. What is increasing function? A function f of x defined on interval ab is said to be increasing or non-decreasing or monotonically increasing on interval open interval ab if x1 less than x2 implies f of x1 less or equal to f of x2 for all x1, x2 belong to open interval AB. Remarks. Strictly increasing function. A function f of x defined on open interval AB is said to be strictly increasing on AB if x1 strictly less than x2 implies f of x1 less than f of x2 for all x1, x2 belong to open interval AB. Graphically, if we consider x1, x2 on x axis, so value of x1 corresponding value of x1 is f of x1 and value of x2 corresponding as f of x2. So graph is increasing from left hand from left to right. So the structure of increasing function is just like this. Slope is positive of this graph. Now what is decreasing function? A function f of x or interval ab is said to be decreasing are non-increasing or monotonically decreasing on interval AB if x1 less than x2, if x1 less than x2 implies f of x1 greater than or equal to f of x2 for all x1, x2 belong to open interval AB. Now, strictly decreasing function. A function f of x defined on open interval AB is said to be strictly decreasing on AB if x1 strictly less than x2 implies f of x1 strictly greater than f of x2 for all x1, x2 belong to open interval AB. Mathematically, graphically, if we consider 2 points x1, x2 on x-axis, so the corresponding value of corresponding output of x1 is f of x1 and the corresponding output of x2 uh, is f of x2. So now if we join x1 f of x1 with f of x2, so given uh, the given point shows in on the graph. Now result, if f of x is differentiable on the open interval AB, then f of x is strictly increasing on AB if f dash of x strictly greater than 0 for all x belong to AB. For example, the function if we consider the function f of x equal to e power x is strictly increasing on R because the derivative of f of x is strictly greater than 0 for all x belong to R. Now if we consider now f of x is strictly decreasing on interval a b f f dash of x strictly less than 0 for all x belong to open interval a b. Example of strictly decreasing function is f of x equal to 1 minus x. Now if we differentiate this function, we get f dash of x is equal to minus 1. Minus 1 less than 0 for all x belong to R. Now point 3, if f dash of x greater than 0 for all x belong to AB, except for a finite number of points f dash of x is equal to 0. Then the function is increasing on AB. For example, if we consider f of x is x power 3, f of x is x power 3, so this function is increasing because derivative of this function is 3x square. 3x square is greater than 0 for all x belong to R except x is equal to 0. So this function is not strictly increasing but increasing function. Point 4, f dash is less than 0 for all x belong to AB except for a finite number of points where f dash is equal to 0. So then the function is decreasing on AB. For example, if we consider f of x is equal to x power 3, then f of x is neither increasing nor decreasing on R, uh, because